Here's a quick video on graphing sine and cosine functions. I'm just actually going to show you sine function, and then I'll explain how it works with cosine as well. So we're going to start off here with y equals sine of x, which is the parent function. We haven't done any transformations to it. It's just the standard function. We start off with an x and y axes. Notice that I have a long x-axis and y, and I don't have a grid here. It's best if it's on blank paper. I pick a spot, and I picked a point right here, and I just put a mark out here, and I'm a particular length. It doesn't matter how, where, but kind of farther down here, and I'm going to label that as the period. Our waves, these are wave functions. They have an oscillation. They go back and forth, up and down, and one period would be one full wave, and so that's going to be the length of one wave. We divide that period in half, and so you'll see that I labeled that as p divided by 2, because it's whatever the period is, whatever this number is, this would be half of it. I'm going to divide each of these little subdivisions again in half, and so I'm going to end up with the period divided by 4. So this tells me the length from each from the origin to each one of these dots. That's 1 p over 4, 2p over 4, 3p over 4, and 4p over 4, the 4 sections. We're going to mirror that over on the left-hand side, but they're, of course, all negatives. Now, at this point, we pick a length on the y-axis, and we mark it with an A, which is going to stand for amplitude. And we mirror that down below, mirror it over the x-axis, and we have it down here as negative A. We then start putting our dots, and we have a dot at the origin because we're doing the sine function, and sine starts at 0 is an easy way to remember that. So sine starts here. If we were graphing cosine, we would be starting at the amplitude instead of at 0. Sine starts at 0, and we're going to go up, down, down, and up again. So you'll see that we put another dot up to the amplitude, back to the axes, down to the negative amplitude, and back up to the axes. We're going to do the same thing. I'm going to mirror that over on the left-hand side. I like to start here. Instead of trying to go backwards and go this way, I just start at the beginning of this period and do the same thing, starting at 0, so I went this dot, like that. And now we're going to connect the dots with a line, and there is our sine curve. Okay. Now the period of the parent function, and that's important, this is the parent function of sine and cosine as well, is 2 pi. So instead of p, we're going to replace that with the number 2 pi. Now remember, these were divisions of the period, so this would be the period divided by 2, otherwise 2 pi divided by 2, which gives us pi. And here we're going to have the period divided by 4, or you could remember that, wait a minute, we just found that by dividing this one in half. So it's going to be pi divided by 2. And this is 3 of the periods divided by 4, or you could look at this now and say, oh, I know my dots are counting, or my axes marks are counting by pi over 2's. So this is 1 pi over 2, 2 pi over 2, which is pi. This would be 3 pi over 2, and then 4 pi over 2 is 2 pi. So I know that I have 3 pi over 2. Once again, you now have the numbers here on the right-hand side, so we're going to mirror it over on the left-hand side as well. Now, let's look at the full equation, the equation that shows all the transformations. We've seen this before, x minus h and plus k. This implies a horizontal shift, a shift that would move this graph to the left or the right, meaning all of these black dots that we did in the beginning, we would shift them to the left or we would shift them to the right, depending on what that number is there. This k is the vertical shift, which would mean each one of these black dots that I put on the graph, I would be shifting them either up or down, depending on whatever this k is. And we do it up or down from the axis, which has a name. We call it the midline of the sine or the cosine wave. And it's the line that goes halfway through, kind of cuts the wave right in half. So what are these other letters? Well, let's start with the A. The A is the amplitude. And the amplitude is this distance from the midline to a maximum. Okay, so we have to pick a maximum. So we could do it here from the midline to this maximum, or the midline to this maximum. And for the parent function, you'll see what's the number in front of sine. Well, the number in front of sine is 1. So for the parent function, the amplitude is 1. So we're going to change that number now. Instead of being an A and a negative A, we need to change that to 1 and negative 1. And now we have the complete graph of y equals sine of x, because we've got all of the numbers on our x-axis, we've got our amplitude marked on our y-axis, and we have 2 full periods of the curve of the wave. Okay, but we have this other letter that we in this transformation function, b, because we talked about period of parent function is 2 pi, but I don't see p in this equation. No, and we don't, but we see this b. So what is the b? The b means frequency. Frequency has a lot to do with physics and the sound waves. You'll use that a lot in your physics class. But frequency is referring to the number of periods, meaning a complete wave, in 2 pi. Remember, a period is a length. The length from the origin to the end of this period, that length is 2 pi. So the frequency is the number of those lengths in 2 pi, meaning it gives us this equation that the number of the frequency, the number of periods in 2 pi would be 2 pi divided by p, because p is a length. And so you'd be, so in this case, up here in the parent function, we have a 1 times x, and so we would be doing 2 pi divided by 1. Excuse me, I mean the frequency is 1, and so 2 pi would have to be divided by 1. That's why I know that what my period is. I'll show you that we have an equation here that says, oh, the period would be equal to 2 pi divided by the frequency. Since my frequency here was 1, I end up with my period equals 2 pi divided by 1, which is 2 pi. Let's look at a transformed function. Y equals 3 sine of 2x. Start off with your axes, get your dots on there, and make your curve. Notice I don't have any numbers yet. It's okay. This is the way you always start every single one of them. You don't need to make it fit the grid. You make the grid fit the graph. So from this problem, we need to figure out what are the numbers that belong on the x-axis instead of these p and p divided by 2 and all that stuff. Well, first of all, we can see right away that we've got the amplitude is 3, so that's the easiest one to put on the grid, is to put our amplitude of 3 and negative 3. We see that our period is 2 pi divided by the frequency. The frequency is 2. 2 pi divided by 2 is pi, so this p is going to change, and now I write down pi. Now I'm going to figure out all of these, because I'm going to take that pi, because that's my period. I'm going to do pi divided by 4, pi divided by 2, and 3 pi divided by 4. And I get those. We do the mirror of those over here, the negatives of them. And now we have the graph of y equals 3 sine of 2x. Next problem, y equals 7 sine of 3x. We start off with our axes. We put in our dots. And we put in our curve. We notice that our amplitude is 7. So we go ahead and mark the amplitude. We find that our period is 2 pi divided by 3. So now that we've got this, 2 pi divided by 3, we're going to be putting 2 pi divided by 3 here. And you could divide it in half, and half of 2 pi divided by 3 would be pi over 3. Half of that would be pi over 6. So we have an idea now that we've got pi over 6's that we're counting by. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And that gives us our grid when we're done.